Our client is DevCom, which is a U.S. Army combat company, and they are producing propulsion charges using traditional manufacturing methods, but they want to shift to additive manufacturing, otherwise known as 3D printing instead, because this allows for more precise geometry. They're currently experimenting with this technology in a small lab where they are producing about 2 pounds of product per day. So our project is to design a facility layout with enough 3D printers and staff to meet propulsion charge production rates at 20,000 pounds of product per day while complying with Division 1.3 safety requirements.
Moving into our approach and methodology, one of the most important parts was the slicer software, which is used to determine printing time and number of pieces produced per print. So we were able to run this software on two different printer models that we were considering. And we've listed some of the key data below, including time per print and pieces per print as well. And based on that data, we selected the Stratasys Neo printer because of the lower total purchase cost and the superior production scale capability. Then next, moving to some of our data assumptions, our facility layouts were constructed based on current demand, not forecasts. And we were provided a ratio from DevCom, which stated that for 3 employees and 10 printers, is a 2-hour initial setup time, a 1-hour subsequent setup, and a 1-hour cleanup time. There are 2 8-hour shifts that run per day. They provided us with a 10% defect rate. And then we have some of the key costs associated with the employees, electricity consumption, and maintenance costs listed below as well.
So with that information, we were able to design 2 layout alternatives for the client. So our first layout was a 10-bay facility with 80 total printers. The main difference in these layouts is that this has almost a 6-foot aisleway and 3-foot blast walls in between each bay. And then compared to our second layout, which has 12 total bays with 96 printers, there would be a 3-foot main aisleway and then also reduction in blast walls based on the client's experimentation on if this is possible at 2.5 feet.
Then we went on to compare these 2 layout alternatives. As you can see from this data table, alternative 2 does have a lower cost per pound produced per day, and that's why we recommend that our client goes with alternative number 2. However, it's important to note that both layouts will meet the propulsion charge requirement of 20,000 pounds per day. So the next steps for our client are to use the dynamic Excel file that we will provide them to calculate space and personnel requirements, and then 2 future state projects would be a more in-depth cost analysis and the design of the pre-print and finishing processes. And then also they want to pilot a 1-bay facility in their New Jersey location. Some of our key deliverables to the client are the dynamic Excel file, as we had mentioned, the number and model of 3D printers needed to meet throughput, and then the 2 layout alternatives. So what are the benefits associated with our project? We provided them the ability to produce complex geometries of the propulsion charge products. They're able to now conceptualize what an additive manufacturing facility could look like. And also, once again, the dynamic Excel file will prove to be very useful.